Hey everyone, try to stay out of the splash zone for today's lab. Alright, today what we're going to do is the mixing water lab. So what I have here is, well, I guess the heart of the lab is I've got a thermometer right here for us, hopefully one that you can at least somewhat read. I've got a container of hot water and a container of cold water, and you can see if I put the temperature probe in here, well look, the temperature plummets down fairly quickly in that one, and it raises up again, fairly quickly over in this one. And what we're going to do is we're going to practice hypothesizing and measuring, doing some estimation skills with this lab and everything. Normally you would fill out this sheet right here and hand it in for a grade. Instead there'll be a short quiz after this that you can do for it. So what we want to do is they have a series of amounts of different temperature waters that they want us to mix together and everything. So the first thing that we need to do for each one of these is we need to figure out what's the temperature of the cold water and what's the temperature of the warm water. So for the first one right here, what we'll do is we'll test this out. We'll kind of check on this. Watch as the temperature plummets down lower and lower and lower. And eventually it should kind of bottom out here. We're at 7 degrees Celsius, down to 6 degrees, still falling. 5, oh, now it's starting to slow down a little bit. We're getting closer to it. Now it's not going to be 0 degrees because that would mean the water is frozen. And this water does have ice in it, but it's not quite that low. Okay, we're down to 4. Can we get to 3? Yes, here we are. We're at 3 degrees Celsius, and it seems like it's really slowing down about now. So I think what we're going to do is we're going to call it at 3. Can we get to 3 point? Okay, 3.6 right there. We're going to call it to 3.6. So, look, here's my marker. You gotta have your marker for this. All right, we're gonna call this the temperature of the cold water, 3.6 degrees Celsius. All right, is what we're aiming at here. The warm water over on this side. Well, let's put our warm water in, and we'll see what happens with this one. All right, so we're going up, 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 up. And what we're gonna do then is, after we write the warm temperature in right here, we're gonna see what do we think, what's our hypothesis? If we mix 40 milliliters of cold and 40 milliliters of warm, what do we think is going to be the outcome temperature? Did we settle on temperature over here? We're at 62.3, looks good to me, so we'll say 62.3. All right, so if we mix 40 of each of these, what do you think is going to be the temperature? What do you think the temperature will be, 40 of each? So, I don't know, if we're starting at 62, do you just take away 4? Or roughly around in there. So let's say 50, I don't know, maybe 58 or 57, somewhere around in there is my kind of guess. So my hypothesis will be, let's say 57 degrees Celsius is going to be my guess that we'll have for this. Then what we want to do is we want to actually measure these together. So what we need is, we need 40 milliliters of cold water. So I've got a little beaker right here and my graduated cylinder. If I put some water in here, oop, that's just a little bit more than 40. I'm going to go back and forth on this. Here we go. All right, so there we go. I got 40 milliliters of cold water. Put the cold water back in there. We're going to do 40 milliliters of warm water. Oh yeah, that steams it up nicely. All right, 40 degrees of warm water. Then what we're going to do is we're going to put it in this container right here. And for this one, I'm going to try not to touch the sides of the container because the container is its own temperature. These two because the containers have been sitting there for a while. This one's warmed up, this one's cooled off. I'm not too concerned about that. But this one, because we're doing a changing temperature, I am a little bit concerned about it. And let's see here, we're at 30 degrees. It's kind of going down, 29. It does not look like my hypothesis is going to be correct at all. All right, so we're hovering at 29.1. Can we get down? I think we've stopped. 29.1. So the actual answer is going to be 29.1. Was my hypothesis correct? Absolutely not. But remember, in science, we've learned something. That's what we're trying to do here. All right, so for this lab, what we'll do is we'll dump out this water right here. We'll get rid of this guy too. And then we're going to start again, right? We'll basically do the same thing again. Now for this, what you always want to do is for the next two, you still want to take a temperature reading, right? This one, you know, maybe it's slightly warmed up because it's been sitting in the classroom. This one maybe it's cooled off a little bit because it's been sitting here in the classroom. So let's see if the numbers still stay the same and everything, right? So we had 3.6 degrees before. Where are we at now? Okay, we're still kind of trucking down on our way down here and everything. So it's at 6.6. I'm thinking it's going to keep going again, a little bit colder here and everything like that. Now this time we're going to write down, you know, the temperature of the cold water. We're going to write down the temperature of the warm water. But this time for our hypothesis, we're mixing 30 milliliters of the cold water and 50 milliliters of the warm water. So more warm water. So we'll see. I was way over with our temperature for this one. But maybe for this one, if I kind of keep similarly, maybe I'll try to get a little bit closer is what we're shooting for with this. So let's see here. It's staying at 5. Okay, it's at 5.5. Will we keep going down, or is that going to be it for this one? It's at 5.4. Let's see if I hold it up a little bit, maybe because it's on the... Oh yeah, there we go. That gets it down a little bit more. It should be pretty similar to the 3.6 that we had last time, but it might have warmed up a little bit. Okay, yeah. All right, so we're going to call it at 4.8 because it actually just went up a little bit and everything. So we're going to call this one 4.8 degrees Celsius. And for the warm water one, this one goes up a little bit faster here. Last time we were at 62.3. Let's see what we're at this time. 59, 60, 61, 62. Oh, there we go. Yep, it's pretty close because it all of a sudden started slowing down. 62.6. All right, so 7. We got 7. All right, 62.6 is what's fluctuating back and forth. So 62.6 right there and everything. So if we're mixing more of the warmer water and less of that, right? Last time it still plummeted down a lot. So I'm going to take more than 4 away this time. Let's call it 40, let's just say 40 degrees, right? 40 degrees Celsius is going to be my hypothesis for this one. We'll see if we can get a little bit closer for that. So this time it is 30 milliliters of the cold water. So, okay, we'll take 30 milliliters of cold water right here. No ice cubes. 30 milliliters. There we go, perfect. 30 milliliters of cold water. And what was it? 50 milliliters this time of the warm water. 50 milliliters. Steaming. Oh, okay, 50 milliliters is way up here. Okay, there we go, 50 milliliters. I should be doing this the proper way, right? Okay, we got that. 50 milliliters. And then when we take our temperature reading now, let's see what we come up with and everything. We were going for 40 degrees was what I was measuring. Well, let's see here. Oh, look, 33.2. Oh, it's hovering right there at 33.2. So that's much closer, right? So let's put this in here. 33.2 degrees Celsius. That is much closer, you know, than our first hypothesis that we had. Okay, we're on to experiment number 3 right here. We'll kind of get rid of any extra water that we might have happened to have. We'll put this guy in here so it's cooling off and everything. And okay, for this next one, we're going to measure 20 milliliters of cold and 60 milliliters of warm. So we're getting more and more warm water seems to be what they're asking us to do for this one. So once again, we're first going to get the temperature of the cold water. So the temperature of the cold water here. Let's see, we were at 3.6 and 4.8. We're already down to below that other one. I don't know why it was kind of high for that other one. 3.8, and it seems to have stopped. Yes, I think so. So 3.8, we're going to put that one in here. 3.8 for this guy. 3.8. And then for the warm temperature, let's see what we get this time. What were we at? We were at 62. So let's see if it goes right back to 62 again for this one. 57, 58, 59. I know, the tension is just amazing, you know. Will it make it back into the 60s? Ooh, it's definitely cooling down a little bit as time goes on here. It's only at 59.6. All right, 59.6. It's definitely cooled off. 59.6. This is why you've got to measure it each time and everything. So this time even more warm water is going in there and everything. So let's see here. We took about 20 off for that one. So 40, 30, let's say 35 degrees. All right, I'm going to go for 35 degrees for this one. We'll see how 35 degrees, and we're doing 20 milliliters of cold water. So let me get some cold water right here. Just 20 milliliters is not very much. Okay, no, just a tiny drop or two. Yep, there we go. Okay, 20 milliliters of cold goes into the beaker right here, and 60 milliliters of warm. So I've got 60 milliliters right here. For 60 milliliters, we're going to do a split. There we go. There's 40 milliliters. Plus we need another 20. No, there we go. I got it just right. All right, 40 plus 20. Those are going to mix together, and let's see, right? Let's see what happens with this. So my guess is 35 degrees Celsius. And, oh, we're at 30. Oh, we're going away, though. We're going away. 38. 38.6. 38.7. Okay, so 38.7.8. Can it get to 30? Oh, no, it's going down now. All right, so 38.7 is what we're going to call it. So 38.7, I'm losing my marker again. 38.7. So you can see, well, still my hypothesis is not perfect. It's definitely getting better, right? I mean, as I keep going down, I'm kind of refining it a little bit. Hopefully I don't mess this up with the last one. All right, so we'll do this experiment one last time right here, right? We'll kind of like test out how cold the water is for this one right here. As I dump out all our containers, make sure they're kind of empty for us. All right, so for this last one, what we're going to do is we're going to put almost no cold water at all, just 10 milliliters of cold water, 70 milliliters of the warm water. We've been using the same amount of water each time, right? We haven't changed anything except for how much the volumes of the ratio, if you want to call it that, of warm to cold water. Okay, so let's see here. If I hold this up and kind of keep it where it's cold, we were shooting for, what, 3, 4 degrees, somewhere around in that range. Okay, we're at 4. Can we get it back down to 3? Yes, 3, 3, 2, 3. Oh my goodness, it's getting even colder, right? The water is getting colder because there are ice cubes inside this water, and the ice keeps melting and putting more and more cold water inside of it, and it's getting pretty, okay, now we're going back up, all right? So let's say 2.1 right there. It's going to be the number for this last one. 2.1. 2.1, and then for our warm water, again, we're shooting for 59 degrees. Can it stay up at 59 degrees, or is it going to be below 59? All right, as we keep going up here, coming down to the end of our lab experience for us today. 55 degrees, 56. It's definitely slowing down. It's cooling off as, you know, some of that heat is, escaping into the classroom around it. 56.4. I might have stopped at 56.4. All right, let's call it at 56.4. 56.4. 56.4. Now, for this one, when we mix it together, right, it's going to go down about 20 degrees, so 40, let's say 36. Let's try it. I'm just going to call it 36.4 degrees. That's what we're going to shoot for here and everything. Okay, so we're going to 10 milliliters of cold water. 10 milliliters of cold water. Make sure that we're measuring properly, getting down here and everything, which I didn't do for the first one, did I? All right, so, all right, we've got 10 milliliters of cold water, which means we're going to have 70 milliliters of the warm water. So that means, let's see here. Go, all the way up. This graduated cylinder, there we go, is 50. So we've got 50 milliliters. And then if we want 70 milliliters, right, 70, yep. That means we need another 20. 20 milliliters right here. There it is. All right, 20 milliliters goes in. And let's see what our final result is right here. I'm looking to try to get 36.4 degrees. Can I get close? Oh no, I'm going up, I'm going up. Oh no, I think I shot too high. Or well, too low, because this is going higher. 41, 42 degrees. Uh-oh, 42.4. It's definitely just about leveled. Oh, maybe it levels out at 42.4. All right, we're going to call it at 42.4 degrees. Marker again. 42.4. Well, my hypothesis for the last one was not perfect by any means, but certainly way better than the original hypothesis was way off and everything. So as scientists, that's what we're doing. We're trying to refine our results. We're trying to get our hypothesis as close as we possibly can and use our estimation skills for, for science and for bettering, whatever it is that the experiment is we're trying to get to. All right? Hopefully this helped you out. Remember to take the quiz, and I'll see you later in class.